Introducing Anubha and Ashutosh, who are giving a talk entitled Mind vs. Machine, the Role of Human Psychology and AI in Security Culture. Take it away, folks.
Hi, everyone. Thank you for being here. It's 5 p.m. on a Saturday, so you guys clearly like security, and that makes you our kind of people. I'm Anubha. I work in product security, and I spend a lot of time thinking about how human behavior affects security risk.
And I'm Ashutosh. I focus on applying machine learning and AI technologies to developing security products. Very excited to be here.
So we'll try to make this presentation worth your weekend brain power. So let's kick off with this visual audit of how the security control is working here. On the left, we have a very dedicated security guard. They are doing some deep threat detection, just not the threats they were hired for. And on the right, we have an employee taking cloud security very literally. He probably didn't notice any S3 buckets, but he's probably seen some good images in clouds. Now, these are funny, but painfully familiar. Because security controls don't just break because of vulnerabilities. They break because of behavior, distraction, misinterpretation, and just doing the right thing with the wrong understanding. So because of that, when we are designing security controls, we need to keep psychology and not just permission in mind. And we're going to focus this talk on that. So first, let's look at what all entities behavior affect. So we have various kind of threat actors. They could be human, organization, or non-human entities like scripts, machine learning tools, etc. These different entities have different kinds of behaviors, and in this talk, we'll spend some time first looking at human behavior and how that affects security, and then follow up with AI behavior and how that affects security. Now, when we are talking about threat actors, one thing we need to keep in mind is every threat actor has its own motivations, capabilities, and limitations. For example, a nation state has vast amount of resources, which a script kiddie cannot match. So when we are designing security controls, alongside behavior, these are the two other things we keep in mind. So let's begin with the very first human threat actor. Humans are the system. We build it, we use it, we fix it, and sometimes paste credentials on Slack. Humans are tricky because even when they mean well, they operate with emotions, habits, blind spots, and biases, things which no firewall can catch. So when humans are involved in the system, we want to secure the surface, we don't just secure it technically against vulnerabilities, we have to secure against the psychology, which means rethinking our design policies, controls, and experiences to account for those. So let's begin by unpacking some human behaviors, which commonly trip up security teams. Just give me access, said no one ever. Or maybe everyone. Wanting elevated access, disabling a security header, or deploying a quick fix without review. These are not behaviors which are driven out of malice. They are usually driven out of things like urgency, a sense of ownership, and just, wanting to avoid red tape. Having a need of control and autonomy is a very entrenched human need, and it connects deeply to our emotions and biases and fears. So over here, security has to stop being a wall and instead act as a path. We have to design controls which allow autonomy while making things secure. Things like scoped RBAC roles, environment isolation, just-in-time access, and education which actually explains why alongside what are really helpful strategies over here. The next one. So many of us have iPhones, and in your iPhone, if you have location enabled for your camera, then whichever pics you take, they automatically have geolocation data. Now, if you share any of these pics via AirDrop or WhatsApp or any other app, your geolocation information also goes alongside it. Many iPhone users may not be aware of this. Or even if they are aware, they might not take the steps needed to remove this setting. So is this malicious? No. It's not malicious, but it's not secure by default. Human beings always go for the fastest and the easiest and the most obvious way to do things. If security features are slow or chunky or hidden or obscure, then they are not going to be used. So the strategy here is straightforward. Make security default. Have security features and also have security earlier in their entire pipeline, into development workflows, into frameworks, into defaults. Remove the choice and make it automatically secure by. So, taking a break from the behaviors, can anyone guess why these protrusions on escalators are present? Yes, correct. Because humans are creative, adaptive, and they use features in ways which designers may not be able to anticipate. And that's where one security responsibility comes in. We are not trying to secure the happy, expected path. We are here to anticipate misinterpretation and novelty. Another example is someone using a casual sharing feature, like public notes or status messages, as a safe space and share something which should actually be confidential, or posting internal links. So strategies to defend here include product-specific guardrails, having very feature-specific guardrails which prevent risky behavior, or having nudges which inform the user of the risky behavior when they are trying to attempt it, and context-specific education. Another one, memory and cognitive overload. Consider a scenario in which a customer support agent is working on multiple cases simultaneously. It's possible that they might share information from one case to someone who had access for another case. Why? Because we all have limited short-term memory, attention span, and processing capacity. When working under pressure or with unclear processes or fatigue, mistakes can happen and the probability of them rises sharply. These are not anomalies, and we should not treat them as anomalies. These are a direct consequence of limited human cognitive power. So there are many strategies here which help work around this, the first one being reducing step complexity, having checklists, automated workflows, and providing very structured guidance. Just-in-time security support, again, in-app prompts and contextual nudges help. Passive safeguards, like single sign-on, which avoid a little bit mental friction. When failures do occur, and they inevitably will, systems must detect them early. So alerts and alarms are our friends over here. And a very final human behavior, which is, I think, the most underrated security threat, is the basic human politeness. So I'm sure many of you have held the elevator door open for someone. Now, if it's not a secure building, that's okay. But the same behavior will come up in secure buildings as well. Why? Because human politeness and niceties are ingrained into us. We are social first and secure second. So if we are going to design controls which assume that people will be assertive when they are faced with an awkward human situation, then they are not controls. they are actually a coin toss, especially if it's dealing with someone who has more power or seniority than you. So instead, we should have preset workflows that remove the social burden, or have just-in-time nudges which inform of what policy to be followed right at that moment when decision is being made. And more importantly, we need to design our systems in ways that they completely remove the need, or at least reduce the need for these awkward situations to occur. So here we've looked at some human behaviors, and now let's look at some non-human entities and how their behaviors impact security of systems.
This is ChatGPT's response for my ask, give me a picture of non-human identities. Needless to say, my prompting skills need work, but we live in a world of automation. Our refrigerator knows when and where to order our supplies, and our sprinkler system knows when it's supposed to rain. We have seen an explosive growth of non-human identities or users in our environments. These non-human users are usually created by a human to automate a mundane task and usually run as a Lambda function in cloud or a cron job on a server. If we trust recent studies, the explosive growth of non-human identities outnumber humans by 45-1. These non-human identities use API secrets, Kubernetes workers, and hashes, which are usually not rotated fast enough. Usually, companies have very set onboarding and offboarding processes for their human users, aka employees. The similar predefined lifecycle management needs to be taken care for non-human identity as well. The keys should be rotated frequently enough. Inactive keys should be deleted. And the principle of least privilege is equally applicable here. So far, humans were creating these non-human users and assigning work to them. Now let's look at a far more interesting kind of machine users. These are intelligent machines, and they have access to business critical data and APIs. They simulate humans, and these simulated humans need to be governed and educated as well. Tasks which are traditionally harder for humans are proving easier for these intelligent machines. Let's take an example, password guessing. A well-known password breaking systems like Hashcat will take passwords from a data breach and apply predefined set of rules. For example, adding some digits or special characters in known passwords to guess the new passwords. Whereas PassGAN, a Gen AI-based system which uses an adversarial network technique to look at these well-known passwords from data breaches and automatically figures out the distribution and patterns of very plausible passwords. In a study in 2020, researchers found that this Gen AI-based system can guess twice as many correct passwords and fast as well. These systems are powered by Gen AI models. We have progressed from just the text-based model to a multimodal systems which can process text, image, audio, as well as video, can converse in a human-like voice with sub-second latency, And all these progress has made in just span of few years. On top of that, some of the models have been open sourced, creating an opportunity for adversarials to take it and use it as they want. In a benchmarking study done by OpenAI, GPT-4o performed on top 10 percentile of the test takers. This is not a great trend for cyber defenders or peacekeepers of modern world. To keep balance, security systems need to evolve with the pace of technology, coupled with still the basic principles like least privilege and frequent audits. But unpredictability is not the only concern. Sometimes AI confidently generates output which has no bearing on facts. Hallucinations. They are the consequence of the way AI models are trained, their limitation to use or to understand concepts generically, and the biases and errors present in the data they are trained on. February this year, a federal court cited 3 lawyers for using fake case numbers in their argument. These lawyers accepted they used a state-of-the-art AI system to generate their motion. Court found that this motion had case numbers, dates, and very convincing and plausible arguments, only that the data was entirely made up. Yes, generative AI can be very convincing, but can be far removed from the facts. In yet another incident, an airline was fined for the information which its bot gave to a fellow traveler. This traveler used their refund policy and expected a refund where it didn't happen. Airline argued that the passenger should have contacted the dedicated human helpline to get the confirmation, but court still found them liable for the damages. How can the businesses avoid such risk? First, we have to build inbuilt safeguards in these AI systems where they cannot use the data in unintended or unpredicted contexts. Then we need to do adversarial training, means throw confusing and deliberately confusing inputs to this AI and expose weaknesses before your product or solution hits real world. You break it or somebody else will. And in the end, having some sort of parallel verification methods, like having another system which uses the same inputs and provides independent output and measuring it, can be a very valid way to detect such errors. Such concepts are very well known in the fields of finance and aviation. Yet, another yet bigger risk is AI's ability to find loopholes and bypass security in some times. Earlier this year, researchers pitted latest AI technology with a well-known chess engine called Stockfish. This is the same chess engine if you would have played on chess.com. That's the engine which powers it. These powerful Gen AI engines were tasked to win against this very open source chess engine. However, it was noticed that these Gen AI engines resorted to cheating, even without being prompted by their humans. They resorted to cheating by manipulating the files in the backend, means downgrading the Stockfish version, as well as manipulating their pieces. This behavior trait exists in humans as well. But persuading smart and dedicated human beings to do immoral acts could be a difficult task. We have to overcome their beliefs, conditioning, as well as fear of consequences. But AI, on the other hand, innately doesn't have an understanding of good versus bad and can be trained to do immoral acts without any consequences. And if AI can find loopholes in existing systems, it can also be used to deliberately influence human beings. That brings us to a very grave situations of social engineering. In a yet another shocking misuse of AI technology, a UK-based engineering firm was duped of $25 million using a deepfake video conference. In this video conference, a finance worker received an email which asked him to join an urgent meeting. And though he suspected that this could be a phishing attack, upon joining that meeting, he saw his co-workers, which he knew closely with, and their CFO joining that meeting. And in that meeting, CFO asked him to transfer a sum of amount, which, seeing directly coming from CFO, he obliged, only to later find out that in that meeting, he was the only real human being. In order to safeguard our interests, security policies must redefine trust mechanisms. We should require to verify the facts through independent multiple channels. And in most cases, social engineering succeeds when somebody rushes or breaks protocol. So in case when the situation seems emotionally charged and things seems rushed, take a pause, double check the facts, perhaps triple check it. Such incidents and AI capability can paint a grim picture, but there is hope. These behaviors aren't just for the academic interest. It's essential that we use them to design our security products and use these technologies to bolster them. Humans and AI behave differently. They fail differently. And they usually use features differently. Human instincts can be rushed, distracted, or emotional. However, AI system can be very persuasive, yet aloof from facts.
So as a final thought, good security isn't accidental. And actually, the major problems that happen are because they are accidental. Good security needs to be deliberate. A deliberate choice based on the threat actor, their behaviors. A deliberate trade-off between scalability, usability, business needs, product and productivity, right? Like we can't say that always make the most secure system, because the most secure system is is something in a box which is not connected to anything. But we have to make these trade-offs and risk decisions conscious. And that's the key takeaway we would like you guys to take. Thank you.
We have a couple questions from Slido, and then time permitted, I'll take live ones and walk around with the microphone. So first question, given that Gen AI coding has been let out of the bottle, do you expect applications to become less secure as more and more developers use it?
Absolutely, yeah. It's a tool which should be used very carefully. It does not take the human out of the picture. Even the code is generated by Gen AI, one should definitely look at it and make sure that it's safe.
One point I would like to make here is we are used to policy being very static because human behavior and human changes take time. But with Gen AI, things change very rapidly. So the entire process of how policy is created and that speed itself need to be rethought of.
And then next one, do you distinguish between LLMs and AI in terms of threat actors from this presentation?
That's an interesting question. LLM has been the talk of the town because of the rapid advancement it has seen. But of course, we are seeing people talking and envisioning AGI or other broader sets of AI. But yes, given that LLM is used so frequently and pervasively today, they definitely pose a higher risk to security. Yeah.
All right, any live questions from the audience? Going once, going twice. All right, let's give one more round of applause. Thank you, Ashutosh and Anubha. That was great.
Thank you.